Sentry's Python SDK has a comment that tells you exactly what is about to go wrong. We can only weakref non-builtin types. The very next line does the one thing that weak reference existed to prevent. You cannot weakref a value error, so the fallback holds the exception itself. And this lives in a ContextVar. So under asyncio, every task keeps its own copy. It is not one retained exception. It is one per live task. Here is what that costs. 200 long-lived sessions, a megabyte each hitting one ordinary error and then staying open. 207 megabytes retained, all 200 sessions still reachable after garbage collection. The collector cannot touch them because a live ContextVar still points at every one. The obvious fix is to store a fingerprint instead of the exception. I tried that first, and the SDK's own test told me I was wrong. A fingerprint cannot tell the same exception captured twice apart from the same error raised twice from the same line. Fingerprinting the address is worse. Stop holding the exception and its address is reused immediately. 2,000 distinct errors collapse into two keys, so keep identity and stop holding the object to express it. Attach a weak-referenceable token to the exception and weakly reference the token. Deduplication behavior is unchanged, and the ContextVar no longer keeps a traceback alive. Same 200 sessions, 2 megabytes, nothing pinned. Then I ran Sentry's own Seer on it. It found the root cause exactly, including that ContextVars are per task under asyncio. Then it proposed storing the type and the ID of the exception, the same trap. Its fix would drop every distinct error as a duplicate. A Sentry maintainer reached for the ID in an abandoned branch. I reached for a fingerprint. Seer reached for the ID. 3 attempts wrong the same way because none of that can express object identity. 5 tests, one of which fails without the fix. 0 regressions against master. It is on a branch against Sentry's SDK, and all of it reproduces from a public repo.